Okay, welcome everyone. If you're coming from the last video, as you should before seeing this one on recursion, I'm going to dive into implementing recursive technical interview questions. And I'm only going to cover the ones that I normally see in interviews. Fibonacci done recursively and iteratively, flattening arrays done recursively and iteratively. And I'll see if I can remember any others, because frankly, I think those are the only ones that I really come across. Um, Maybe we could re-implement depth first search for a fun, let's just do those. Okay, so I'm going to start out by iteratively doing Fibonacci. So implementing Fibonacci. So let's actually go to the iPad for this. I like my favorite thing to go to. Let me pull it up. And the idea with iteratively is that you can basically just lay it out and implement it. What does that mean? That means, what is Fibonacci? 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. You can do that. You can keep doing that in a loop, and then you're good. At least I think so. So what I like to do is I at least like to draw it out. So we have 0 plus 1 is 1. And then you have 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 2 is 5. So let's do the step. 0 plus 1 is 1, right? 1 plus 2 is 3, right? 2 plus 3 is 5. And 3, 5, I don't know, something else, right? 8, right, of course. But now we need to loop through this, and it's fairly simple. So each iteration is what we're looking for. We want to iterate up to 5 times to see what Fibonacci done 5 times looks like. And what does it look like? Well, we have it here. We have 1, 2, 3, 4. Maybe it's, what would the answer be there? 5? No, 8? 0, 1, 2, 3. Interesting. So to me, 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. And this usually counts as like a first one for some reason, right? So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the 5th output, I think. You can double check me on that. But we're going to do this iteratively, and that's let's just start from there. So function Fibonacci in. So how long are we going to do this? Well, I think maybe a for loop makes sense. Yeah, because we're doing it so many times, but we need to keep track of things. So what do we need to keep track of? Well, we need to keep track of current value and past value. It's basically current value plus past value equals new value, right? So let's have that. Let past val, current val, and new val, maybe. I don't know if we want to keep track of this. So we'll see. For let I equals 0, I less than n, I plus plus. And what are we going to do here? Let me zoom in, see if I can't make this a little less blurry on the screen. That might be a little easier to read, even though my handwriting sucks. What's up? Okay, so what do? We have 0. So it's like I is the pass val almost. So you have 0, 1, 2. No, that doesn't make any sense. That doesn't make any sense. That's the starting val. Let's start pass val at 0 equals 0. Current val equals 1. And then we'll figure out the new val on the way. We could compute it right here, but we're not going to. So I think we should probably get rid of this, frankly. Okay, so we're here. We have pass val is 0, current val equals 1. That leads us to do 0 plus 1. So maybe we do want to keep track of, no, what do we want to do? We could say cur val equals past val plus cur val. Is that the right order? No, it's not. Actually, it's Ooh, that's a tough one. You know what? I am going to keep track of new val here, just in case it makes sense. Let's delete that. Why didn't I like that? Well, I have to keep track of these numbers. And if I change this number, it needs to become pass val. And the new val needs to become pass val plus cur val. So we're going to keep track of that, right? So new val equals past val plus cur val. Then we need to change them. Then we need to change it. We need to say past val equals cur val. And then we need to say current value equals the new value. And then that's interesting. So you see how we had to do that in the right order. We want to calculate the new value with the old past value and current value. And then we got to change the past value to be what was once the current value. And then the current value needs to be what is now what we just decided the new value was. And that's kind of how I think we have to loop through it. And then at the very end, we'll return new val. I feel like this is right, and I could totally be wrong. I think it's good though. I want to test it out. Let's test it out. Oh, wait, okay. We said this would equal 0, right? Let cur val equal 1. Let new val. Nice. And we don't let it equal anything. Right? So for let I equals 0, I is less than n, I plus plus, an old school for loop. We say new val equals past val plus cur val. Then we say past val equals current val. And then we say cur val equals new val. Nice. And then we return new val. I kind of want to see along the way what these numbers look like at the top of the loop. Console.log, we're going to say loop. And we're going to give new val, past val. Actually, let's do this. Start from age, cur val, new val. Nice. I think that's smart. Let's see. So fib of 5 is 8. What? Oh, is that expected? I don't know if that's expected. I think it is because we didn't count this first one as, we didn't do 0 plus, we didn't count this first one as a thing. So 1, 2, 3, 4, well, it looped 5 times. 3, 4, 5. You know what? I guess Fibonacci at 5 is 8. Was that the same thing we had when we did it recursively? I don't remember. So let's see. I think, let me check the book. Oh, they basically did something super similar. Let's see. They did I equals 2, I less than. Oh, they started I at 2. Oh, interesting. 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 So they started I at 2 in here. Fibonacci of 5. 3. Oh, that's too much. Why is that too much? I think it's too much because it said I equal to 1. That makes sense. Why did that make sense? Yeah, I think Fibonacci at 5 is 5. So why did it make sense to set it at 1? Because that counts the very first one. Why did they set it at 2? I don't know. I don't know. They got a totally, they kind of did it a little differently though. Oh, because in the end they return A plus B, they return past value plus current value. So they loop, but they don't do it quite the same way we do. And they're doing more addition in the return. So that's why. It's because they did an extra thing of their own. So we just did it all inside our loop because we're cool. And that's how it worked. So that's easy. That's straightforward. That's hard to remember. Why this off by 1 error? Hard to say. Hard to say. I think it's just a matter of keeping track of, hey, what do we count this first base case as? Maybe the base case should be the first iteration. So when we get here, we've already done the base case 0, 0 and 1. right? I've always been a little confused at that, so maybe it's best to memorize this. Maybe. Okay, cool. I'm going to take a 5-minute break, but when we get back, and it's not recorded, so don't worry. When we get back, we're going to go over flattening array, which is the most common recursive problem I have ever faced during interviews for recursion. All right, be back. All right, all right. So now we are going to take on my arch nemesis, flatten deep array. So what is the problem? And this one comes up a lot. Imagine you have an array, and it looks like this: 1, 2, nest, 3, 4, more nest, 7, 8. Sorry, 7, 3, 2. We're going to nest it again. No, we're not going to nest it again. We're going to have a number 3, and then we're going to nest it. Look at that. Aren't we cool? We're going to nest that deeper. All right, that's just going to be a single one, right? And then we're going to have another single one. I'm getting a little feisty because this thing has tripped me up in interviews before. Well, the funny thing is, I always remember the recursive version, but not the iterative version. The iterative is supposed to be a lot easier, but I don't know why it's not for me. So we take A, it looks like that, but what it needs to be is 1, 2, 3, 4, 7, 3, 2, 2, 3, 3, 2, 2, 22, 23. Right? We needed to be that. And that's called flattening an array. And it may seem really obvious at first, but it's not always super duper obvious. And I think sometimes when you get this one, you want to kind of check with the input. Sometimes the input will be like this. We'll also have like an object thrown in there at random. And you want to be sure that you're still doing things properly. And you want to be like, hey, well, if there's an object with an array in it, do I flatten that array as well? Right? And just ask your interviewer, right? If they want to fool you like that, then it's up to them, right? It's up to them. Sometimes they just want to see you work through this. I've been in interviews where they're like, oh, okay, great job. And I've been in other interviews where they're like, that that iterative approach is not going to cut it. And I was like, oh, why not? And they're like, oh, well, we want to do it without certain things. So I'm going to show you what those certain things are. But first, we're going to do the recursive version of this. So I find this one to be a little bit simpler in terms of recursion than the other recursive problems in the book, frankly. And so, when you go over this one, you practice Fibonacci, in my opinion, you're good to go when it comes to recursion. These are the major 2 ones. Maybe you'll run into other problems, but I just haven't. I just have not. So let's check that up. I just randomly saw this note that said check for proof of induction on page 631. And that is actually a super useful concept for recursion because it works by induction. That's interesting. I think maybe we should all look that up. I'm going to look that up later. Interesting. Okay. Anyways, sorry for that ADD. Let's go into my iPad, and I'm going to share. It is not ready. Let me do it anyway. All right. There the screen. Go. Come on. All right, so let's just do a new page. Okay, so we have this array and we want to flatten it. Array 1. I made this one ridiculous because you kind of want to deal with some edge cases here, right? You want to make sure you got your edge cases covered, but you also don't want to confuse yourself with an example. So there's trade-offs. You might even benefit from smaller versions of this, right? So just heads up there. So if I were to do this visually, I would say something like, okay, and start at the first one and just iterate down, right? Now, you could do that while you're solving recursively or not. Okay, so I'm looking at 1. I'm like, okay, the 1, that's fine. So we have this new array with 1 in it. And we'll look at 2. Oh, 2 is fine. Yeah. Okay. Then we look at 3. 3 is an array. What should we do? And well, I basically wanted to do the same thing I did earlier. So I'm going into this array and I'm like, okay, well, let's check out 3. There's not an array. There we go. Well, let's check out 4. Well, this 4 looks pretty good. What about this one? Oh, that's an array. Well, what's inside the array? Well, it's a 5. Okay, well, 5. Look at this one. Then the array's done. Cool. What's next? Oh, we got 6. That's fine. Okay, now we're here. Well, we got an array. Okay, well, let's do the same thing we just did. That's where the recursion kicks in. We're like, okay, this is an array. Let's just call the function again because the function is doing this perfectly, right? And so that could be a really good way of approaching it. Now, I kind of like doing, earlier I said something to the effect of, let's not use red. I like using purple, so it doesn't seem so ridiculous. Okay, so function, flat array. Not even going to spell it out. Flatten, whatever, flat array. Make it flat. Okay, so we're going to do that on the array. I want to kind of keep track of this other array. Let new array equal this, right? Now, some interviewers might have a problem with, well, you are creating a new array with this. That means you're going to have a little bit of extra space taken up by it. If there's sticklers for that, then there are other ways of doing this. And maybe I'll Google it after, actually, because this problem is not in the book. It's crazy. It's like the most commonly asked problem after Fibonacci. Okay, so we have this new array. Then I'm going to have the actual function flatten. And it's going to take in that array, right? These are not the same yet. You still got to call the function. Don't think they're the same. Actually, you know, just to make that a little clear, so there's no collision, I'm going to name this flatten sequence. Cool, why not? Okay, so we're going to do this thing. So we're going to take the array. If sequence, hang on, there's an array dot is array static function. You want to know about this one. Is array sequence. Then we call return. Now we don't need to return anything. Flatten sequence. We'll just call flatten on, oh, this is interesting. Hang on. I don't think that's right. So I'm thinking of if we're in this one, it's kind of like, what would be a good base case for this? Oh, I don't know. I'm already struggling. Okay. Maybe this isn't the right way to approach it. What's a good base case here? Well, we basically want to say the base case if sequence dot length equals 0 return. That way we're through with the entire array. I think that might be good. So what are we going to do? We're going to take in, let's take in just 1, 2 right now. 1, 2 will be the input. Oh, base case and build. Okay, so you see where I'm looking at this example and I'm like, how am I going to pull this off? If I look at this example instead, I'll be like, okay, that looks a little bit easier to digest. So let's try that first. All right, so we got 1, 2. You say while, we could say, let's say value will sequence at 0. And then we could say something like while value array, while not array dot is array value. While that's not the case, what do we want to do? We want to just push it on a new array. Value. Then it's going to stop. And then I'm gonna be like, okay, well, what is that would take care of this one, wouldn't it? That's going to push the values on. So we need to expand our examples so that we can do a little more. Let's say the next value is this array here, 3, then we have a 4, right? So it is an array now. So now we need to do something. We need to flatten oh, we're up here. So the value, okay, so we need to be careful. Oh no, we're inside. So value equals sequence at 0, new array dot push value, or no, I plus plus maybe? Yeah, value equals, oh, we need an index to track this, don't we? Yeah. Let x equals 0. We'll do this here. Index plus plus value equals sequence at index. Probably could have used a for loop there. Value equals sequel at index. Okay, cool. And it does that while the value is not erased. So once it is, it's out of this while loop. If value, like if there is an actual value here, then we want to basically flatten value, right? And then that is going to go here. So 3 is going to be called. And we're going to say let value equals sequence 0. That's 3. And we push that to the new index. And then we up it. The next one is undefined. We're done. We're done there. We're done. We can return. Right. So and then what though? We have this 4 after it. Oh boy, how do we deal with that? I think the idea is that this while loop is no longer going to work for us. We're stopping this while loop as soon as this is found, and then when it's done, it can't pick up and do the next one. I want to make this a for loop. Oh no, that really messed up some of my stuff. Great, we're going to push. Cool, that's value, I promise. Horrible handwriting, I'm sorry. So undo. So what do we want this to be then? Well, let's say for, we could do a for each. Yeah, let's do that. Sequence. Yeah, that way we don't even have to keep track of index. Sequence dot for each value. Right, then we can get rid of all this. Look at that. I was doing a bunch of unnecessary stuff, maybe, potentially. We'll see. And so now we're going to do this. We're going to say if array dot is array value, we're going to call flatten value. Otherwise, else, we're going to call all of this. So let's remove some of this stuff. All right. Else, we're going to call all of this. So if the array is array value, flatten it. Otherwise, let's just push it on. And we don't need to change the value. We can just do that. Nice, that's really clean. Look at that. We don't even need, hang on. We don't even have to do all that stuff. I'm going to select this and we're going to move it up right here. Nice. That kind of coincides, that conflict, whatever. Okay, else push it onto the array. Yeah. All right. That's pretty good. And then return new array. No. We need to call flatten array. And then we return new array. All right. So this is my favorite method of doing recursion. When you need to keep track of a value, instead of dealing with a bunch of crazy return statements inside the actual recursive function calls, just pull it outside of that recursion thing and let it update that with a nice little closure. So that I think that does it. Let's see. Let's see. All right, so we have our crazy A up here. Let's have that one be our array, that one in particular. And we have our function Flatten array. Inside it, we have function flatten. It's going to take in the sequence, whatever. And we're going to say if, well, actually, you know what? It'll return anyways. We don't need to check it for the length of it is 0. Sequence dot for each value. If array dot is array, there's that function. Isn't that nice? Value. Flatten value. Else new array. Oh, we didn't let new array equals this. Else new array dot push value. All right, then we call flatten on array. We return new array. Shot in the dark, huh? Let's try it out. Oh, new array is not defined. Oh no, why not? Oh, new R is not defined because I was an idiot and didn't spell this right. Flatten array. Hey, it did it. Look at that. Oh my God, look at that recursion. Oh my goodness, so nice. So simple too. Isn't that good? Wow, look at that. I just want to look at that for a second. If array is an array, flatten it, otherwise push it to new array. Oh, that's so clean. I like that. There are alternative ways of approaching this, and we'll Google those soon. But now we need to do the iterative approach, and the iterative approach is always the one that tripped me up. So this is going to be super, super important for me, maybe even for you. It'll be instructive one way or the other. Okay. All right, and here we go. So function, zoom in for you. Function flatten R with the R. So this one is a little different. Why is that? Because instead of doing the check during, well, there's two reasons. One is that when you're being interviewed for this, you might get asked to not create a new array. You might be asked, hey, don't do this. Don't say let new array equals this. Do it in place because it can be, sorry, recruiting. So don't create a new array. You can do it in place. What does that mean? Well, earlier you saw me do this during the recursive one. I just put stuff in there. Now they want to say something like, okay, if you see something like this, just turn that array into this without giving a new array. Same but not equal, right? And so so that's the thing. And we want to do it in place somehow. How can we do it in place? It's tricky. We're gonna do splice. And the last time I did this, I failed it. So maybe I'll fail it in front of you right now. We'll see. Good practice either way. So let's start again with a simple case and evolve from there. So let's say array is 1, 2, right? Super simple. And what are we going to do? Let's see. So let's do, well, if I was going to put that into, well, it already is an array. That's ridiculous. Why am I doing that? Let's do 1, 2, 3, something like that. This will be our input. 1, 2, and 3. So I'm going to take the array, and I'm going to do an old school for loop just because for eaches are not as good at doing like in place stuff. I equals 0. I is less than array.length I plus plus. Okay. So I'm going to start here at 1. I'm going to say if, oops, you're not purple. Array of 1 is fine. So if it is an array, we basically want to, interesting, we basically want to loop what we're doing again. This is where I usually get tripped up. So let's see. If the array is an array, or I'm sorry, if the value is an array, let's move this down. Okay, I'm going to say let value equals array.I. And if array.is array is value, we want to do something. What do we want to do? Well, let's see. I have a few ideas here. One is we could just place all of value inside inside array, and that would be interesting. My concern there is, you know, will array.length, is that going to be a constant number, right? If I increase the size of the array during this for loop, will the for loop go on for longer? And I kind of want to test that real quick, actually. That is an interesting question. So let me test that. Okay, so let's do 4. Oh, there we go. 4. Let's 0. I is less than, actually, let's have an array. A equals 1, 2, 3, 4. Good. I is less than a.length I plus plus. All right. If I equals 0, we're going to say a.push 1, or items. That would be nice. 1, 1, 2, 3. We're going to have to push all those. And then we're going to say console.log I. And that should tell us, oh, 0, 1, 2, 3, 4, 5, 6. It did it 6 times, but the original length of the array was 4. So it looks like it goes up as it does it. That's so cool. Let's see it. Let's try that again. We have I, and let's do, you know, let's do a.length, console.log a.length. That would be interesting. Oh my God, look at that. 4, 0, 7. Well, we push it. It became 7, then 1, 7, 2, 7. Nice. Look at that. So for loops are really amenable to that. That's pretty cool. We're going to go back to my iPod with that knowledge. iPad, not iPod. Good Lord. What year is it? Okay, here we go. So we're going to say if array.is array at the value, we want to basically place it onto the original array at that point. So we need splice for that. So array.splice. Now, what was the, how does splice work again? I'm going to Google that. You're welcome to Google it as well. Array splice. Array splice. Here is the prototype. We used it earlier. And array splice, basically you have up here, splice. You have index, number to replace, number of elements to replace. That's going to be 0 for us. and element to replace with. And we're going to see if we can't spread that element one out. Yeah. Okay, the elements to add to the array beginning from start. Well, let's try that out. Let's practice on splice. I'm gonna actually show you what I'm looking at here. I went to MDN, right? I was basically like array splice. Then I saw MDN. All right, so we're going to test this out. Another test. Get used to splicing, right? So let's do 1, 2, 3 dot splice. We're going to do it at index 1. We're going to delete nothing. And then we're going to say, maybe if we say something like dot, 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 1, 2, 4, 4, 4. That would be obvious, right? What does that do? Oh, A equals, oh no. Let's do A equals 1, 2, 3 first. 1, 2, 3. All right. And then we'll up here, we'll say A dot splice on this stuff. There we go. 1, 4, 4, 4, 2, 3. Nice. So it started in index 1. That is here. So it pushed the 2 up and it put all those 4s in there. That is awesome. So what does that tell me? For me, for one, that tells me if, well, you know what? Yeah, I think that tells me everything. Well, I want to check at this index thing. So if it does it at index 1, that's where it starts. Is that if that's where the array is, if it's like 1 array is like this, and we are like A dot splice at 1, I'm going to do it 0. I'm going to say dot, dot, dot 2. Actually, we want to replace 1. We got now 1, 2, 3. Ah, we did it. We did it. And we do want to replace something. We want to replace it with its own contents. Brilliant. Okay, that is awesome. Let's go back. Did screen mirror song and dance. Oh my God. All right, all right. This is so fun now. Array.splice, we're going to do it at I. We're going to replace 1, and we're going to do it. Wait, hang on. We're going to say dot, dot, dot value. Nice. The winning answer. I think that's the winning answer. Else what? Else you leave it alone. Yeah, else you leave it alone. Nice. Then we just return array. Are you kidding me? Is that it? I think that's it. If it's an array, do something with it. If not, don't do anything with it. Oh my gosh. I literally failed an interview over this once. Are you kidding? It was this easy the whole time. Oh my God. Practice. This is why we practice, folks. Don't just not practice something because you're like, oh, I did it once. You know, it's funny. For one, I've been asked this interview question twice. One was in a job that I did get right. I did do it iteratively. I did do it recursively. And the second time was in a job I didn't get. And I did the second, it was like the second interview. I did it a year later. There was a year difference. The first time I got it right, the second year, I didn't. That's nuts. You got to practice. I didn't practice. I got cocky. I'm not going to lie. I was like, I don't need to practice flattening array. I did that for like 2 jobs ago. And then look at me now, not working where I was going to be working. That's okay. You live and learn. A company, you ask? Facebook. Maybe. All right. If array dot is array value, then array dot splice I replace one of them, do it with dot 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 value. Oh, didn't return array. equals. Where's that crazy A? Where's the crazy A? Oh no, here it is. This one. Flatten array A. My God. My God. So simple. Really, really simple. Really, really nice. Really well done. Really simple. Good Lord. There we go. Maybe we can make it crazier. Let's make A crazy. Let's see what happens when we throw an object in there. Didn't do anything. It is just fine. Do we do anything even crazier? Let's do like 1, 2, and do another crazy nested array sequence. Unexpected end of input. Whoops. What was so unexpected about it? Oh, we need another one. There we go. Flatten that. Look at that. We flattened the whole dang thing. And it was a very simple algorithm that used to trip me up back in the day. I could see why no one would let me pass that interview if I didn't get that algorithm right. It's so simple. Iterate through it, and then splice it onto the array. If it's, if it's an array, replace the array, and then just destructure it onto the array. And then return it because you're done. Oh, that is so simple, so straightforward. All right, cool. So that is flattening array iteratively. We did it recursively. We did Fibonacci iteratively. We did it recursively, and then someone jumped on the call. So we're basically done here. And I'm going to stop the recording here.